Hey guys, this is a video to help you guys remember how to get from mass to particles or particles to mass. I'm going to be doing numbers 13, 14, and 15 for you guys from your homework tonight. Question number 13 says, how many grams are there in 4.5 times 10 to the 22nd, so I'm going to write that down, formula units of BaNO2. We learned that the first thing that you have to do in all of these problems is that you have to break the compound down and find the molar mass of that. So you're going to list out the elements that you see in your compound first. You see Ba, you see N, you see O. And then you're going to count the number of atoms that are present in each of, the number of atoms present of each element in the compound. Ba has only one because there's no subscript telling us there's a greater number. But then we learned in class that anything in parentheses still gets treated like it would in a math class. It gets distributed by what's on the outside. So this 2 is going to go right there, and it's going to go right here. Inside the parentheses, we see that there's only one N, so we're going to say 1 times 2, and that means that there's 2 N's present in this compound. Inside of the parentheses, we see that there's 2 oxygen. So we're going to multiply 2 times 2, and we figure out that there's 4 oxygen in this compound altogether. Then we're going to multiply it by the atomic mass, the average atomic mass that we find on our periodic table. Ba's atomic mass is going to be 137.33, so I'm going to write that down, 137.33. N's atomic mass is going to be 14.01, and O's atomic mass is going to be 16.00. Now you're going to multiply the numbers. So 1 times 137.33 is 137.33. 2 times 14.01 is 28.02. And 4 times 16 is 64.00. Once you've found and you've done the multiplication for these numbers, what you've found is the individual masses of each of those elements in the compound. But we don't want the individual masses. We want the total mass. So when I say total, that means that we add it all up. So you're going to add up 137.33, 28.02, and 64.00, sorry, 0.00 in your calculator. And you're going to get 229.35. And we're going to say that's grams per mole. So when I write that unit, that tells me that there are 229.35 grams per every 1 mole of BaNO2. After you find the molar mass, you're going to convert. So you're going to start with a T-chart. We're going to start with what we were given. We were given 4.5 times 10 to the 22nd formula units. How do I know that's what I was given? It's because it's the only thing in the problem that has a number in a unit. So I'm going to go ahead and write it exactly how I see it. 4.5 times 10 to the 22nd formula units. Remember in class that we said that we were going to shorten formula units to FMU. I want FMU to eventually go away. So the only way that you can do that is to get them to cancel out. The only way that they'll cancel out is if you have FMU on the top and FMU on the bottom. So I'm going to write FMU on the bottom. No numbers yet. We always do units first. I can go from FMU to moles. So I'm going to put that unit on top. Moles is not what I need though. In the problem it says how many grams. So I can't stop here. So I want moles to cancel out. So the only way to cancel something out is to have it the same on the top and the bottom. So I'm going to transfer that down to over here. But we do have a conversion that gets us from moles to grams. So I'm going to put grams on top. Now, we know that the number 1 is the only number that can ever go in front of moles. So 1 and 1. And then we just found the grams of BaNO2, and that's right up here. So we're going to transfer this number and we're going to bring it right down there. Okay, so you're going to plug that in to right there. And then we have one other number that always goes with any type of representative particle. And the representative particles are if you have an actual particle, or if you have formula units, or if you have ions, or if you have molecules, or if you have atoms. Anytime you don't see a G, you're going to put this number. So the number is Avogadro's number, which is 6.02 times 10 to the 23rd. After you have all of your numbers and units in the right places, that's when you're going to start crossing out the units that are the same on the top and the bottom. So we're going to cross out FMU and FMU here, and we're going to cross out moles, and we're going to cross out moles here. Now all we're left with is to work with the numbers. So we multiply everything on the top. So that means that I'm going to have 4.5 times 10 to the 22nd times 229.35. And then I'm going to create my line because I have one number on the bottom, and that's 6.02 times 10 to the 23rd. Make sure you keep numbers with exponents in parentheses, just so you'll be able to remember how to do it in your calculator. So I'm going to push this over to the side, and then I'm going to show you how to do the math. Okay? So I have 4.5 times 10 to the 23rd, closing out that parentheses. I'm going to multiply it by 229.35, and that gets me 103 times 10 to the 26. Then I'm going to divide that by the 6.02 times 10 to the 23rd, and I end up with a decimal number. I have 171.403. Remember, I only need 2 decimal points after the decimal, but we always look at the first 3 numbers. This is going to round to 0.40 because the third number is less than 5. So our answer is 171.40. And our unit is going to be whatever's not canceled out in our T-chart. So that means it's going to be grams. Now, let's do numbers 14 and 15. Okay? So here's number 14. It says how many formula units are there in 9.34 grams of LiCl? Got to find the molecular mass or the molar mass. So break it down into elements. LiCl. No subscripts anywhere, so that tells me that it is 1 Li and 1 Cl. So I'm going to write 1 and 1. I'm going to multiply both of those by whatever atomic mass I find on the periodic table. Li's atomic mass is 6.94, and Cl's atomic mass is 35.45. Any number times 1 is itself, so 6.94 and 35.45. Those are individual masses, so we need to total them up because we're trying to find the total mass. So that means I'm going to add 6.94 plus 35.45, and I'll get that that's 42.39 grams per mole. I'm going to box that in. Okay, so now we can start our conversion from grams to formula units. So we're going from mass to particle units. So that means that I'm going to have a 3-section T-chart, and I'm going to start it off with 9.34 grams. Grams has to cancel out, so we'll put the grams on the bottom. We can't go from gram to particle, so we have to go through moles, so we're going to go gram to mole. I can't stop with mole, so I'm going to put mole down here so that it'll eventually cancel out. And then I'm going to put my ending unit, which we saw after how many in the problem. So I'm going to write FMU out here. Okay. Now we can start plugging in our numbers. We know that 1 always goes with mole. We just calculated the G over here, so I'm going to transfer that number to here, so 42.39. And then I see FMU, which is a representative particle, and it always gets Avogadro's number in front of it. So that's 6.02 times 10 to the 23rd. Crossing out units that are the same on the top and bottom. And now we're going to multiply the numbers that are on the top. So that means that I'm going to have 9.34 times 6.02 times 10 to the 23rd all divided by 42.39. I'm going to go to my calculator now. Okay. 9.34 times 6.02 times 10 to the 23rd equals, divide that by 42.39, and you end up with 1.326 times 10 to the 23rd. Remember, I only want two numbers after the decimal place, but we have to look at the last three after the decimal place to determine what our rounded number should be. So I see that it's the third decimal place is a 6, which is bigger than 5, so that tells me I got to round up. So that becomes 1.33 times 10 to the 23rd. And then I'm going to stick whatever unit I didn't cross out on the end, which means FMU, as my unit for the answer. And box in your answer, please. Okay, last problem. All right, so we have how many grams do 4.3 times 10 to the 21 molecules of UF6 weigh? UF6 a compound, so break it down into its elements. 1U, because there's no subscript. 6 F's, because it has a subscript of 6. Go to your periodic table. Find U. U is going to be in the very bottom of it. It's element 92. And it has an atomic mass of 238.03. So you're going to write that down. 238.03. And fluorine is element number 9, and it has an atomic mass of 19.00. So now what you're going to do is you're going to do the math for it. So 1 times 238 is equal to 238.03. I just said 1 times the number I had. It's itself. Then you're going to say 6 times 19. 6 times 19 is going to be equal to 114. Masses of the individual. We need the total mass, so total means to add. So we'll do 114 plus 238.03. And that's equal to 352.03 grams per mole. That's the first part. Now we're going to do our T-chart, because now we can start to convert. My given was 4.3 times 10 to the 21st molecules. Remember, you can never shorten the word molecules down, because if you do, then it's going to look like mole, and it's going to get confusing. We want molecules to cancel out, so molecules must go on the bottom. We can't go from molecules to grams, so we're going to go molecules to mole, so mole will go on top. Can't stop at mole because it's not asking me for mole, it's asking me for grams. So I'm going to build another T-chart. And I know I can get from moles to grams though. So I'm going to take moles and put it down here because I want it to cancel out. And then I'm going to put G on top because I know that I need grams. We know that 1 always goes with mole. We're going to plug in our G because we just found it. Our G is right here, so it's 352.03. And then we know that molecules is one of those representative particles, and the representative particles always gets Avogadro's number, which is 6.02 times 10 to the 23rd. Cross out units that are the same on top and bottom, so molecules and mole. Multiplying across the top, so I've got 4.3 times 10 to the 21st times 352.03, and I'm dividing all of that by Avogadro's number, which is 6.02 times 10 to the 23rd. Now we're going to plug all of that into our calculator. So I've got 4.32 times 10 to the 21st times 352.03. I'm going to divide that by Avogadro's number. And I see that it comes out to be 2.526. We look at the third to see if we round up or down. 6 is bigger than 5, so we round up. So we're left with 2.53 grams. Box it in, and then you're done.